So today I'm going to talk about what I see as some of the steps forward to moving beyond carbon neutrality, but also to kind of set the context here a little bit more about, despite talking about carbon, I want you to know that carbon isn't the only game in town. So my name is David Diaz. I'm Director of Forestry Technology and Analytics at EcoTrust. We're a nonprofit based in Portland, Oregon. I'm actually located in Seattle because I'm also a PhD candidate in forestry at the University of Washington. And most of my work and background has come from ecosystem science, conservation finance, and intensive computation. So I also have not come from the kind of life cycle world. I have about a decade of experience working more about forest carbon markets and things like that. So you'll see kind of as I go through this, there's some things that kind of coming with that background and perspective led me to a lot of confusion that I think a lot of you are probably also experiencing as you kind of try to wade through life cycle assessments and things like that. So to kind of start off from the beginning, I think we've gotten a pretty good idea of this, but forests matter. That's why we're here talking about this. The carbon balance in forests exerts a global influence on our climate. So at least if you just care about climate change and carbon balance, then you should also care about forests. Related to that, we have a lot of businesses now that are acknowledging the importance of forest management into how products are made and trying to make important decisions about where do I get my wood and recognizing that there's a climate crisis. And again, I think it's also important to ground this in the fact that forests provide fundamental benefits beyond carbon. This involves food, clean water, shelter, not just for people, but for everything else that lives on this planet. And of course, in the United States and in the Pacific Northwest in particular, we've got some of the most productive ecosystems in the world. So that gives us a lot of opportunities to work with. So I was a little kind of surprised earlier in the webinar series. Part of that is my background, like I said, coming from carbon offsetting. But when Kate kind of asked some of the presenters, what's the opportunity for buying wood from carbon-friendly forests or forests that are storing more carbon and things like that? And the response was, I think there's a lot to do downstream, in terms of the efficiency and transportation and all of that. Coming from someone who's been working in carbon offsetting for a while, this has been more of what I've been looking at. We have this new term that's come up in the past couple of years called natural climate solutions. And this is related to how different lands can be managed intentionally to add more carbon to the system. And as you can see here, this is from an article that was published in Science Advances a couple of years ago. Forests dominate this and dominate this kind of portfolio of opportunities here. It's not an accident that when carbon offsetting gets started in the 1990s, tropical forest conservation was the first type of carbon offset there. So I think there's a really clear indication for me that there's a reason to believe there's additional carbon that you can be storing in forests through intentional management. And I've put improved management here in quotes because traditionally when you have people producing articles about carbon and climate change, when they talk about improved, they're just talking about carbon balance. So I think when as a forester, you think about improved management, there's a lot more than carbon that you want to think about there as well. And there's a lot of people that are putting lots of money into adding carbon into forests. So I think this kind of idea of carbon neutrality is something that a lot of people are acknowledging that we can do better than carbon neutral. So here's a couple of examples of major entities that are investing millions of dollars to do active forest management and conservation work across the United States. Again, a lot of this focus so far in this entire webinar series, but also in my presentation is going to be focused on embodied carbon. So I thought this graphic here was a pretty good illustration of what we're talking about when we're talking about embodied carbon. Obviously with forestry here, you could add a forest behind this manufacturing facility as well. But so we're not, in my presentation, I'm not going to be going into the operational carbon or end of life and things like that. I'm just going to be talking about getting a product to a builder, what's been involved in that so far. So I borrowed some, this is a slide that Reed delivered earlier And I've taken a couple liberties with this slide and the following slide just to highlight a couple things that I want to talk about here. Reed gave an excellent presentation talking about general approaches to forest LCAs. And I'm going to focus on two of them here. These are the most common approaches that I've seen applied for forest product LCAs. And one is this scenario one, where you're looking at carbon removed from the atmosphere before harvesting while that tree is growing. And the other is kind of taking a supply area approach, where you're looking more broadly across the landscape. And when trying to address this question of are you carbon neutral or not, Reed kind of highlighted approach number one and number three. I've added, to that a little bit here to try to generalize this a little bit more. So I want to highlight here that carbon neutrality is a conservative simplifying assumption. It's intended to make the accounting easier. As someone who spent most of my career modeling forests, I can tell you that it's really challenging to get the numbers right. But so one of the things that's most important to recognize about approach number one is that when you have this traditional LCA approach that leads you to this biogenic carbon neutrality, like Reed mentioned, it can miss deforestation unless there are constraints added. And so this is typically where that, is the land area of forestry across the region decreasing? Is the inventory decreasing, et cetera? The other thing for me, having spent most of my career trying to get more carbon into forests, it's also blind to all of the landowners that are intentionally trying to add carbon to the landscape, okay? When you think about this wood supply area approach, number three, which is what I'm going to run with for the rest of the presentation here, I've generalized this a little bit to where essentially what you're looking for is a non-declining carbon stock across the landscape over time. If you have a non-declining carbon stock, then you can make this conservative simplifying assumption that the wood is carbon neutral, that the forest is carbon neutral, and make your accounting easier. You don't have to. So this is an option to simplify the accounting. And what's exciting about this approach number three is that it allows you to account for both gains and losses across the landscape. And it is sensitive to how long of a time frame you draw that you're interested in, and how big of an area you're interested in. So I think Reed kind of set the context for this really well. And this, I want to make sure to give credit to what inspired me before I saw Reed's presentation. So this is an excellent, very short, it's a 3-page article that describes the basic methodology that I'm going to be using today to try to add this, what I call upstream embodied carbon to life cycle assessments. So here's the basic formula, is that you look across some area of interest and you calculate carbon stock change in the forest. You're going to set a time frame for doing that calculation as well. The next thing you're going to do is you're going to calculate the amount of timber that was produced from that same area over the same time. Okay, and then you divide number one by number two. All right. So what you've got now is how much carbon stock on the landscape can be attributed, not exclusively attributed, but can be attributed to the timber that was produced from that working landscape. Okay, and so what's nice about this kind of accounting approach is that this is separated from all of the downstream life cycle impacts that are really well reflected in most LCIs and LCAs and EPDs for forest products. So this can be offered essentially as a supplement to try to move beyond zero. So I published some research a couple years ago that was using a simulation approach to doing this kind of work. But what I'm going to be focusing on today is using observational data. So we're not simulating anything here. We're actually looking at data that's been produced by the NASA Carbon Monitoring System. And so they've used an algorithm called Land Trender, which takes a time series of imagery, is trained on LiDAR data and field inventory. And they've produced a 30 meter by 30 meter resolution map of the lower 48 states on an annual basis from 1986 to 2018, showing above ground biomass. So this is a pretty good proxy for forest carbon stocking that we can track over time at a very high resolution. The other thing that we've got is a completely independent set of timber harvest reporting that's been collected by states and federal agencies for many, many years. So the data that I'm using in this presentation come from the University of Montana, and they've been compiling reports that have come from state and federal agencies into a consistent format. And they, in all of these states, there is county level reporting on an annual basis by different owner types. So we have a huge amount of information that we can use to try to do this calculation that I shown earlier. And this is just showing how we update that formula, saying we're using this carbon data, we convert it to the unit that we care about. We're using the timber output reports, and we convert it to the units that we care about. And then we do this calculation to get at this upstream embodied carbon. I'm going to walk you through an example where I've done this across Washington State. This is intended to be kind of proof of concept, just to indicate whether there is something worth looking at in the upstream forest carbon balance. So we're looking at different ownerships in counties across Washington State from this time frame. So the type of data that we can use for this, we have ownership data compiled from the Rural Technology Initiative, the Protected Areas Data Set of the United States, and US Census data. So each color here in this map here on the top left corresponds to a different type of owner. This black area corresponds to reserved forests. So these are areas that are not actively managed, and they're excluded from the analysis. We also look at filtering out areas that are not forest cover. So we're only going to be looking at the biomass information that comes in a forest cover. So this is another satellite-based data set that's freely available that estimates forest cover at repeated times. We're going to use counties as kind of a useful reporting unit that's come from a lot of the timber reporting. And this is kind of analogous. It's not quite the same thing as what Pat was describing as a wood basket, but it's intended to offer the same type of insight. And then we've got this biomass data. So here's a map of just a single snapshot in time showing what the above ground biomass is across Washington State. So when we take that information, we can break it out by ownership. I've broken out here both by east and west side. So the top row of graphs is the east side of Washington, where we have much more drier forests, and on the west side where we have moist forests that are more productive. And what I've done here is it's very similar to the way that a lot of greenhouse gas inventories are done at the national scale and all of that, is that I benchmark it to a year. So what I've basically said is for each owner group, have they added carbon or released carbon compared to where they were in 1990. And what each of these graphs is showing you, the dark line in the middle is the median across all of the counties in that region. And then the bands as you go further out correspond to percentiles. So you've got the 40th and 60th percentile, which are the darkest band around that dark line, etc. And you go out until you get to the 10th and 90th percentiles at the very end. And so you can see that we can now get this kind of time series information about how carbon stocks on the landscape are changing. Now this is just talking about the numerator, of that embodied carbon calculation, but you can see that different owners in different regions are behaving differently, and that the ownership and management objectives of those owners contributes a lot to how the carbon changes on the landscape. So before I show you some embodied carbon numbers based on what I've calculated, I want to kind of throw some context out here. So when we look at a couple of different EPDs and LCAs for glulam, I've converted this into units that we're going to be presenting elsewhere as well. So 1 cubic meter of industrial roundwood. So about 42% of that cubic meter of roundwood will end up in glulam if it's used to make glulam. And when we try to unpack the embodied carbon emissions associated with the production of 1 cubic meter that gets turned into glulam, you end up with about 5 kilograms of CO2 that are related to the operation. So this is the harvesting, the tree planting, the hauling, etc. About 20 that correspond to producing lumber, and about somewhere between 20 and 40 kilograms of CO2 that are associated with taking plain dried lumber and converting it into glulam. You contrast that with how much carbon is actually retained in the product, and these things are all dwarfed by how much is going on in the product there. But hopefully that can give you a sense of some of the numbers that are about to come up on the next slide here. So what I'm showing you here is the same calculation now, to where I'm looking at the distribution of counties across Washington. And what I've done is I've taken that carbon stock change from 1990 to 2016 and divided it by the timber output that was produced by that owner in that county over the same time frame. And what I really want to highlight here, I'm showing for each different owner, these percentiles. So these are percentiles of the counties. So 50 is the median county for the Forest Service, for example, is negative 234. These are big numbers, okay? So we have a huge swing but it's not zero, okay? If you look across this table, both on the east side and the west side of Washington, very few of the numbers are close to zero, okay? And so this kind of highlights, you know, an opportunity here for builders and people that are interested, like Kate was asking earlier, where can I get the wood that's being produced by forests that are adding carbon to the landscape? We have an idea that there are certain places of the landscape that are adding lots of carbon, that are doing much better than zero. We have some places on the landscape that are doing much worse than zero. So this is what the graph looks like now if we normalize it by timber output. So we're saying, well, different counties produce different amounts of timber. This is actually more getting at the supply of wood that comes across the landscape. So one of the things that you can notice here is that a lot of this is shifted to the right. You know, the shift from adding carbon to the landscape versus releasing carbon from the landscape has moved to where there's much fewer, much less of the wood supply is coming from carbon releasing activities over time. But what this also highlights here is that the assumption of carbon neutrality for the wood supply is conservative. You know, we have more than 50% of the wood that's being produced in Washington state, at least, is coming from places that are adding carbon to the landscape over time. So I think there's kind of a missed opportunity that's being left behind when we kind of make the simplifying assumption of carbon neutrality, at least for Washington forests. So the great news is that these data cover the entire United States, right? So we have this NASA carbon monitoring system data that's available across the country. The Forest Service has also produced a similar coverage that breaks the land ownership, forest ownership across the country down into major ownership types. So I think it's exciting to say that we will be able to do these type of calculations across the rest of the United States relatively soon. And I really look forward to getting into that. I mean, you know, Kate kind of described in the run up to this that you know, we haven't been able to cover all perspectives in this. I think that the series so far has done an excellent job of covering what typically comes up in attributional life cycle assessment. We've had some mentions of consequential life cycle assessment, but I really want to highlight that a lot of the really tricky issues related to substitution or forest protection and conservation really come into play when you zoom out to this kind of how do the changes that I want to see in the world ripple through to other people. So if you're trying to make a decision that's an individual action that you might take, such as, should I use this material or that material in a building project, attribution of LCA is often good enough. You know, it depends on whether you're comfortable with your simplifying assumptions. And I'm hopeful that you'll see this and say, hey, maybe I should try to find out whether or not there's carbon being gained or lost across the landscape that my wood came from. But it raises this question that if you're actually trying to make sweeping policy decisions that have much broader impacts, attributional LCA is not good enough, okay? And that brings you into a world of having to set up counterfactuals or what-if scenarios, where you're going to pretend like your models can do a good job of indicating how markets, policies, people, and the environment all interact. And so there's a lot of assumptions involved in that if you do want to get at what's the impact of wood product substitution versus other materials on a large scale, or what's the impact of setting aside reserves for forests on a much larger scale. So the other thing that is kind of a now for something completely different here is I've just spent the past 20 slides telling you how to quantify carbon and why it's a big deal compared to the assumption of carbon neutrality. Now I'm going to shift to something to tell you that carbon is the tail, it's not the dog, at least when it comes to forestry. And so I want to kind of highlight here is that we can conceptually think of forest management in these kind of two buckets here. So I think that it's important to say that you should buy climate smart wood and you should buy more of it. And I think the distinction here that I'm going to draw with a couple examples that follow is that climate smart forestry I'm using to refer to things that are thinking holistically about adaptation to climate change, resilience of forests and communities, and mitigating the climate crisis, okay? Carbon-friendly forestry I'm using just to refer to how do we mitigate climate change with natural climate solutions, for example. And so the real question is, what is this? What is this area in climate smart forestry that's not carbon friendly, okay? And why I think that you shouldn't only use carbon as the indicator for deciding where you get your wood products from. Okay, so this is a good example of a process that's been going on of Western juniper invading traditional shrublands across the Intermountain West. So this is a picture from Central Oregon, where Western juniper has been growing across the shrub steppe. And from a carbon perspective, that's fantastic. These trees are adding a huge amount of carbon to the landscape. Not quite as big as the forests on the west side of Oregon and Washington are, but there's a lot of carbon that these trees are locking up. The problem is that these trees are very thirsty. They're also crowding out a lot of the native vegetation that occurs there. So there's been a lot of work to actually invest in juniper removal to provide better habitat for endangered species, whether that's steelhead or whether that's the sage grouse. And those types of things are climate smart, okay? Even recognizing that removing juniper may involve a carbon release, it's still important that we do things like that. Here's another article that looks at juniper management and highlights that it has important water implications. Like I said, these trees are very thirsty. Okay, so apart from something like this, you've also got people in the mix here. So as Pat described, we've been excluding fire from many forests for about a century, and that's led to conditions that are intolerable in terms of catastrophic wildfire that are now taking place across the US West. And so the question is not, can we avoid fire? It's how do you want your fire, okay? So this is an example of some of the fires that were occurring in California recently, and some of the prescribed burning that can be done to try to restore fire to the landscape in a way that's more historically consistent. This is a great example. Pat had some images from this same watershed, but I want to highlight here that the forests are not just about carbon. Like I said, it's the tail, not the dog. So Denver has been using utility fees from people that are paying into the water utility to do active forest management of their watershed. The idea there is that they want to avoid the risk of sedimentation into their water supply that might occur due to a catastrophic fire, okay? So there's a huge investment that's going on here. And so even if you looked at this forest and said, oh, these people are decreasing carbon across the landscape, you should still buy their wood because they're doing great things for forests that protect people's water supply. Okay, and so I just want to kind of mention that active forest management is an important tool in the toolkit for climate adaptation and climate smart forestry. And it's definitely not something that you should get hung up on carbon being the only game in town. With that, I really look forward to taking your questions and responding by next week. You can reach me at this email address, and that's all I've got for today.